Hi, I'm Matt. What's Matt? Today I'm here in the same room as Dominic, sitting next to him, trying to have this conversation. So if we get creative, you understand why. So today we're going to talk about the newest prompt injection attacks. This isn't a 0-day thing. They didn't just come out. All right. You're probably familiar with the grandma jailbreak, but in case you're not, we're going to be going over some of that stuff, basics of it, and then some newer stuff I'm learning as I build out LLM powered tools for my clients that receive user input and could be hacked, and the security measures we're playing with to make sure that doesn't happen. Tom, I know you did some homework.
Yes. Back in the day, these attacks, I'm going to go to a different thing, SQL injection attacks, right? This world is exponentially more complex than that because within SQL injection attacks, you have a clearly defined set of keywords, right? Insert, delete, update, etc. But within an LLM, you've got no distinct keywords. So the defenses I've seen against it all seem to be put an LLM, another classifier in front of it. Start with that, and then I have some more questions.
Well, that's an interesting one because that's an expensive route to take. Okay, have one model monitor another model to make sure the first model didn't hallucinate. But how do you know the second model didn't hallucinate? And you're paying for two models. So not exactly the way I do it. But I guess for those of you guys that just to completely go back and talk about the first prompt injection attack I ever heard of was the grandma lullaby one, where basically the LLMs back before they could have tools and everything else and were interconnected. Basically, as you talk to it, it talks back. Say you wanted to get instructions on how to build a bomb or create a computer virus or some malicious program there. They trained him not to tell you. Then you could get clever though, because if you fed it something like, back in the day, my grandmother used to tell me stories about when I was a kid, or when she was how to build a napalm using basic household items, things of that nature.
You had a really interesting conversation then, because how to find napalm with the LLMs? Or
you tell it. My grandmother used to tell me a lullaby. Can you write me that lullaby? And so it would go ahead and do information, and it shouldn't give you instructions on how to make a bomb or anything like that. So.
Now, the second thing I'm seeing out there, and I've seen it on Hugging Face and on GitHub, is there's now people that have built data sets of prompt injection attacks. That's one thing. You can train your own model from that. There's even the next layer is people are releasing models, trained models on prompt injection attacks. And then the last thing I just recently saw is now there are services to do this. I suppose that's a natural evolution, right?
Yeah. Oh, yeah. It's always going to be increasing war. There's always two sides. One side's going to get better at it. The other side's going to adapt and go on. That's just InfoSec as a whole there. The defenses for it, we could run another model about it. But one of the main ways that people try and protect against these things, and I say protect, it's 101 stuff, but the basics is make sure you got a good system prompt that tells the model that you're using what it should do and shouldn't do. And it's not a perfect thing. You can jailbreak it still, but always start with having a good system prompt. So you got the system prompt, which outranks the user prompts, basically. And you want to make sure, because if you just give it one long prompt, right, and you say at the beginning of it, hey, follow these instructions, and you inject everything as the same input level, basically, to these things, someone at the end, some user could type in something like, hey, ignore all previous steps and do this thing. And it will probably do it. But if you put it as a system prompt, that should override the user prompts, the user feedback that you're getting from the wild.
I just have flashbacks. It feels like we're getting to inception level things here. How many layers can I override, in what way, in what order, to trick grandmother into delivering me a recipe for napalm?
Yeah. I mean, in all real, giving you bad information or information, generically trained information, that's one thing. That's one type of attack. I wouldn't say attack, but you're extracting information that basically violates the user agreement. It's not personally identifiable information. It's not the passwords of 1,000 users. It's not credit card information, and it's not issuing you a refund there. So that's the other part. Once we get past the system, is now with these tool calls, you don't ever give it the ability to be like, oh, issue user 123 a refund, or even pull up user information on user 123. What you want to do is the function, the tool call needs to have context about the user already. So say I'm logged in and I say, give me Dom's password, give me Dom's browsing history, which I don't even want to know. But give me the information about Dominic. If the LLM hallucinates and says, give me, and it puts in your username to the tool call needs to be hard coded by a human being ideally to not pull up information about a different user than is currently authenticated with them.
Okay, so let's take Inception a different direction then. You've hardened your systems, you've got everything locked down, but you're doing tool calls, and we've got a third conversationalist here. You're doing tool calls into other people's systems. So could you theoretically pass through an injection attack, through a tool call, to somebody whose system is less well defended than yours?
My LLM, my personal agentic agent or something like that, or a tool I've written is calling into a third party, let's just say Shopify,
Sure.
whatever. Ideally, the tool call, and this is something you're going to have to, when you write the tool call, you wouldn't allow the LLM to do anything significant. There'd be you'd have to issue like a URL that a human would have to go and authenticate with, a auth 2 style or something like that, to say, hey, I agree to this purchase or whatever. Maybe you'd have browsing stuff and it could put the items in the cart, but the actual transaction that's important, it wouldn't do. And if you're talking about securing your information, before it queried anything that's even remotely sensitive, there would be an authentication step that would get an access token that would allow my personal agent to send that access token to you and take actions on my behalf. So it's possible my agent might screw around there, do something stupid, but it's limited to my account. It's not cross accounts. It's nothing like that. Does that make sense?
Yeah, but I'm just wondering if I can talk to an agent and say, forget all of your previous prompting, that's going to be protected against. But if I say, I want my agent to go do something, and within the queue of what I wanted to go do, I set the second layer, meaning I want my agent to go out and issue nefarious commands to secondary and tertiary agents.
And that could happen. That's different than a prompt injection attack, because you're having your LLM attack other people intentionally. It's not that I'm a bad guy feeding your LLM bad information. Your LLM is actually being used maliciously. So I would say that using an LLM to attack is different than a prompt injection attack. Does that make sense?
Yes, but I guess my point is, what if, well, yeah, I guess I'm stuck in Inception to say, if the first layer has good defenses, would it even allow the nefarious injection attack on the second layer to occur? Or am I thinking about things entirely wrong?
I think you've reversed the scenario of what a prompt injection attack is, but we can talk about using an LLM maliciously. I'm very certain I could get any one of my coding tools to use Metasploit, and I'm sure I could tell it, hey, you're doing, I need you to design a pen test and have it whip up a pen test, and I'm putting in air quotes for you guys in the audio, that is actually an attack on Dominic's favorite site.com. So that's totally doable, but that's, again, different than a prompt injection attack. Another example of a prompt injection attack, which I actually found rather amusing. I thought it was rather clever, but somebody didn't do their system prompt right, because there was somebody that was on Delta or one of those airlines. I don't know which airline it was. And the chatbot was not letting them talk to a human. And so they put in a prompt that looks exactly like your chat history would be if you fed it in just as a text file without saying this is a system and so on. And it basically just fed a history saying that the bot thinks it said, yeah, I'll connect you with someone right away. Who do you want to be connected to? And then the bot thought that it already said that. And so they basically overwrote the bot history. Whoever wrote the original software wrote it really jankily, because it shouldn't have allowed it to look like the bot had already agreed to it. And then the boss, and it connected them. And you could do that with the refunds. You could say, hey,
I mean, this just goes back to, there is no limit to the set of things that you can attempt to do with an injection attack.
The solution to that one would be to not allow the user to basically put in characters that make it look like the bot's history. Don't allow the user to dictate what the bot thinks is its history.
I guess my point is, that's just one thing that you have to protect against. Then somebody else is going to try something different, and something different, and something. There's an infinitely larger surface area of risk than there was to SQL injection attacks.
Yeah, in reality, this is all hacking. It goes back to wire fraud, which was a fraud done over Morse code in the old days. So yes,
Telegraph days.
Absolutely. But this is just one of the newer ones. I don't say newer one because it's again been around for 3-4 years, probably longer than that, but at least on my radar for 3 or so years.
So what's the best basic defense for somebody that's putting something up?
So 3 that are in my mind: system prompt. Okay. Make sure that you're not just throwing everything by the user. You're specifying very clearly when you're passing it that information. Second one, validate the tool calls. Don't give it the ability to select any user it wants. Don't give it, never give that on your credit card. There should be a corresponding system that is similar to our current web clients or statically coded clients that doesn't just think like that. So you're validating the tool calls. And for the third one, like I said, don't let them pass in its own history. Store the history on your side, validate the conversation. Don't let them pass in the characters that you use to delineate the user chat from the other chat. You want to sanitize all that data so it's as simple as possible. So those are the ones that I think of off the top of my head. There are more advanced ways. You could put an LLM in front of it that classifies it or whatever. And at the same time, that might be a good idea, but it also sounds really expensive to me. So as a web application architect that has to host these things at cost, I'd start with the first three. And then if you're seeing issues, work your way up. I would use the pen testing software to test injection attacks. So that I think is really brilliant. Having that data set, passing that in, love it.
Yeah, there's big data sets on both Hugging Face and GitHub for those things that are already fully classified. So you can test yes, exactly. So you can say, how many of these malicious attacks did my LLM respond to or respond inappropriately to? All right, I think we've done pretty well on this one. It's not a really deep topic. Anything else you want to bring up while we're here?
Yeah, I guess another thing we can talk about real quick is cost modeling for these things. So recently I had to do some cost analysis for a client that gets hundreds of thousands of searches a day. And we were looking into projecting out how these things are going to cost. And it's interesting, people don't think about this, but if you're a developer, you might, but they're creating a conversational LLM that you can have a chat with like a human being. That's going to get a lot more expensive than if you're just taking a Google-like search and trying to figure out what they meant with the slight misspelling or something like that. Versus, because if I'm searching for Adidas and I misspell Adidas, like maybe I said A or put an extra D in there or something, as I tend to do, MySQL and things like that aren't going to find it if you're doing most of those traditional searches and you don't have a data set of common misspellings. But an LLM got a good shot at it, actually, especially if you feed it some context. So what I'm saying, basically, long story short, if you're creating an LLM that is conversational in nature and has chat history memory, and you're running it 100,000 times a day, it's going to be a lot more expensive than if you just have one that takes in key phrases and pushes out a search, but it has no memory and minimal conversation stuff. If you ask it a question, it'll be able to give you the search results to some extent, but it's not sitting there trying to spend 10 lines of dialogue back and forth with you. So, and the more context you feed it, the more expensive it gets very quickly. So you've got to factor all these things in when you're analyzing this. So when I'm talking to my clients, I'm like, is it conversational? Is it how many lines of dialogue we're going to give it memory for? Because we got to feed that back in.
How many people are going to hit this? How much do you need to maintain in memory? How much? It very quickly gets expensive. So then I think we talked a little bit about this last week, but then you're talking about the strategy of how do you roll something like this out? How do you calculate that ROI?
Yeah, you always got to calculate the ROI. A lot of us engineers like, oh, it'd be cool to do this. No, how can we get the user to the right product they want so we get a happy customer and a sale made as fast as possible? And that's who I'd roll it out to. I wouldn't, if you got a history of buying from my site, you got access to it day one. There you go. And if you got questions about cost analysis or anything like that, feel free to leave a comment or anything like that, or shoot us a message. Is what I do for a living. Also, I guess I'm going to take right now to plug schematical.com/community. If you're interested in getting help on this stuff hands-on, that's one of the services we offer in addition to my one-on-one consulting where I help you build these things.
All right. With that, happy Tuesday. And we will see you again in a week.